Okay, what I have here is my latest waste oil furnace conversion. This one's based on a Bryant 127,000 BTU per hour oil-fired furnace. This was pulled out of a home that was converted from oil heat to natural gas. And this one I have set up to run on a variety of waste oil products. It'll run on waste motor oil, hydraulic fluid, transmission fluid, any kind of mineral oil like that. It'll also run on any type of bio oils like vegetable oil, peanut oil, or anything like that. I built a furnace similar to this several years ago to heat my shop, and it's been working almost flawlessly for the last several years, and we've really enjoyed the free heat. I built this one here for a friend, and I've incorporated several design upgrades to this one. Just a quick tour around the furnace here. What we have is, on the outside of the furnace, we have our two temperature controllers right here. And what these do is they control the temperature of the oil at the nozzle and also the temperature of the oil in the holding tank. We have our air pressure regulator and solenoid valve out here. And what this does is it takes air pressure at whatever your shop air is and reduces it down to about 10 to 20 psi. That's the air pressure we use actually at the nozzle. And right here we have our oil siphon tank. And what this is, it's a small tank that's attached right to the side of the furnace here. And it's heated with a small 110 volt heating element that's commonly used in RV hot water heaters. And we have our suction and return lines here. And I use the existing oil pump in the burner to continuously circulate oil through this. And what that does is it makes sure that the oil is evenly heated, so we're not sucking up any cold oil into the nozzle. And that's an upgrade from my old furnace. My old one used to siphon oil directly out of this tank, and it took so long to actually get to the nozzle that on a really cold day it was already cold by the time it got to the nozzle, and it wasn't burning quite as efficiently. Now, this tank also has a float switch in it. And what that does is, as the level goes down, as the furnace uses oil, the float switch engages a relay inside the furnace that turns on an external oil pump from whatever tank is supplying this to pump oil back into it. And it cycles on and off just a couple times every hour. And a safety feature I've incorporated into this furnace is that the relay that the float switch controls is timed. So if for some reason the float switch fails, the pump will only be allowed to run for 20 seconds at a time, and this will prevent the pump from pumping several hundred gallons of oil onto the shop floor. What I have right here is a lighted push button switch, and this light comes on whenever the float switch engages the oil pump. And so if I ever come out and notice that the light is on and my oil pump isn't running, then I'll know that the 20-second timer is timed out. And that'll tell me that maybe my filter is clogged or that the float switch has failed or something like that. Pushing this push button switch resets that 20-second relay. So if I was ever to empty the tank to clean it out, and it actually did take more than 20 seconds to fill the tank up, I could just push this button a couple times to reset the pump and allow it to finish filling up the siphon tank. Okay, the heart of this furnace is the Beckett AFG burner. And this burner is the one that actually came with this furnace. And I reused a number of the existing components on this burner, but the actual nozzle setup that's down inside the blast tube in here I've pulled out and replaced with a custom machine aluminum nozzle block and a fertilizer siphon type nozzle. And what this nozzle does is it takes the compressed air, and it's a Venturi, and it actually sucks the oil up through it, and when the air flows through there, atomizes it and sends it through an electric arc. That electric arc is generated by the transformer right here. And then I've reused the existing primary safety, and what this does is it has a flame detector down inside the tube, and what it does is it won't allow the burner to light if it detects that there's already flame in the heat exchanger. Meaning if you spilled some oil in there and there's a fire burning in there that's not supposed to be in there, it won't allow the burner to spray any more fuel in. And then what else it does is, if the burner doesn't light when it's supposed to, after a small amount of time, then it locks the burner out and prevents it from spraying any more unburnt oil into the heat exchanger. So if you come out here and this red button's popped up, then you know that you got some kind of problem. For some reason the burner wouldn't light. What I got here is my DIN rail with all of my relays. I have two solid state relays that are controlled by the temperature controllers, And I use solid state relays for those because they turn on and off fairly frequently, and a conventional electromechanical relay would wear out rather quickly with all the power cycles. I have my time delay relay right here, and this gives my 20-second maximum run time for the oil pump that pumps oil up into my siphon tank. And if this is timed out, the only way to reset it is to hit the red reset button on the outside. And then I have my main power relay, and this just takes an input from the thermostat. It's just a regular digital wall thermostat like you'd see in a house. And whenever the thermostat requests heat, then that turns this relay on, which energizes all the components inside the cabinet. And then I have my heater safety relay. And what this relay does is, if the level in this oil tank down here is too low, it prevents the heater from turning on inside of there. If you actually uncover the heater element, it can burn up if it's not completely submersed in oil. So if the oil level's too low, this relay just doesn't allow the heater to turn on. Now for the fuel system in here, I've reused the existing oil pump that's on the side of the burner. And this oil pump continuously recirculates oil from this tank right here and pumps it back into the tank. And it sends it right through this loop right here where this brass T is. And then the siphon nozzle draws its oil from this T. So we're actually circulating a lot of oil through this loop, and then the siphon nozzle just draws a very small amount through it. And I have it set up right now to run at about 1 gallon an hour, so it consumes approximately 1 gallon of waste oil for every hour. I adjust the fuel flow rate based on the pressure regulator out here. The higher the pressure, the more suction it develops, and the more oil it actually sprays into the combustion chamber. And then I adjust my air with the pump's air valves right here. So I can adjust my fuel-air ratio pretty easily based on the type of fuel that I'm burning or how hot I want it to burn. Okay, we're going to go ahead and fire up the furnace. Okay, and you can see when the thermostat kicked on and requested heat, our temperature controllers are energized. This top one right here shows the temperature in our oil tank down here, and the bottom one shows the temperature in the nozzle block. And these values right here are in Celsius. So we're actually looking at about 90 degrees Fahrenheit in the tank and about 180 degrees Fahrenheit at the nozzle. And what will happen is once these get up to their pre-programmed set points, then it will allow the burner to light off. So as you can see, the nozzle temperature is getting right up there. We're almost at our set point right now. The temperature of the oil in the tank, that moves a little bit more slowly because it actually has to heat up all the oil that's in the tank. So it'll take about 1 to 2 minutes before that oil is up to temperature. Hey, what I have inside this oil tank is some 15W40 waste motor oil. And it's just regular oil. It's been drained out of a diesel engine. So as you can see, the heater's tending to churn up the oil right here and make it froth up a little bit, and that's pretty normal. You can see the furnace is now operating, and it's producing some pretty good heat. And it's burning perfectly clean, even though it's burning waste motor oil. There's no smell, no smoke coming out of the exhaust pipe. Now the fan's kicked on, and it's actually recirculating hot air. Right now there's no ducting hooked up, so it's just blowing hot air out into the middle of nowhere, but you can feel it's plenty warm. You can actually see the heat waves reflected on the shop floor right there. this heat exchanger has some pretty good inspection ports. We can open it up and actually see what the flame looks like inside. I've adjusted it for a good clean burn, and the flame about equal to the way that it was when it was still set up from the factory.